Okay, in this video we're going to do 3 practice problems. This will be for 6-1, day number 2 in the law of sines. And the directions just say use the law of sines to solve, if possible, the triangle. If 2 solutions do exist, find both. Round answers to 2 places. And we are going to sort of do them out of order here. Let's look at 29 first. They give us this information here. Angle A is 120. And that will be true for both triangles if 2 exist. I don't like the look of that 2. There we go. Side A is 25. Side B is also 25. So here's our setup, and if we look at our top triangle, we've got one side and the angle across from it. So that will be our first fraction, 25 over the sine of 120. And that's equal to, the other side we have is 25, but we don't know the angle across from that B, so we'll just set that up as 25 over the sine of angle B. So now we cross multiply. We'll get 25 times the sine of 120. So we're going to have a 25 times the sine of 120. And that's equal to the other diagonal, sine of b times 25. But then to get this sine of b alone, we're going to divide both sides by 25. Now, it's kind of one of the weirder problems here, this odd one that I picked out. So if we start working on this mathematically, we can punch this in our calculator, and we'll get that as a decimal answer. And then once we get rid of this sine by taking the sine inverse of this decimal over here, our calculator will tell us is 60 degrees. So we're like, okay, we didn't run into any problems. We found this angle. So let's go back to our triangle. If this angle B is 60 degrees, is it possible to have a triangle here? No, because we've got these two angles together take up 180. There's nothing left over for angle C. Now remember in class, as soon as we found this angle B, if we wanted to check for a second triangle, we would subtract this angle from 180. So this angle B in the other triangle would have to be a 120 degree angle B. And in this case, there's no way we can have a triangle because here we're already over 200 degrees and there's only 180 degrees to go around. So in this case, for number 29, no solution. 23 is up next. So angle A is 110. Side A is 125. That will be again true on both triangles. And here side B is 100. All right, looking here, we've got a side and the angle across from it. 125 in the 110 degree angle. So that gives us a fraction of 125 over the sine of 110. And that's equal to the other known side, 100, over the sine of angle B. Equals 100 over the sine of angle B. So here we cross multiply, and we're going to get the sine of B is going to equal 100 times sine of 110 divided by the 125. So we're going to punch that in our calculator, get the decimal, and then we're going to sine inverse. So in this case, angle B turned out to be 48.74 degrees. 48.74 degrees. Remember to round to 2 spots. So up here in this triangle on top, this angle B is 48 point, come on, decimal point, 48.74. Now to check for the second triangle, we take angle B and we find the complement. Or excuse me, supplement. So we're going to do 180 minus the 48.74. This angle B in the other triangle is 131.26. So if this angle is 131 and this one's 110, we're way over the allowed degrees for a triangle. So there is no second triangle. So we can get rid of this and go back to the top triangle. So we only got a couple more things to figure out. Angle C here, well, we've got the other two, the 110 and the 70 or 48.74. So that would leave us for angle C 21.26. 21.26. Oops, that's not very good. 21.26, and then we got to find this side C. I always recommend using the given starting proportion. So here we're going to go back to the 125 over the sine of 110 and set that equal to this unknown side C over the sine of 21.26. 0.26. Cross multiply and solve for C. C is approximately 48.23. 48.23, and I guess they did not give us units for that length. So here there was only one possible solution. So if we're thinking ahead, no solution, one solution, this one is going to have two possible solutions. So here we go. Given info, A is 110. Side A is 125. Ooh, I went to the wrong one. 27, there it is. Okay. Angle A is 58. 58 degrees. Side A, 11.4. This thing will not do a decimal. 11.4. Use like a little X there, 11.4. And side B is 12.8. 12. Come on, why won't this do? There it is. Come on. 12.8. So just like all the other problems, we look for the first side and the angle across from it. So there is our 11.4 over the sine of 120, or the sine of 58 degrees. And that's equal to, our other side is the 12.8 over the sine of B. So we cross multiply, take the sine inverse to get angle B alone. Angle B here turns out to be 72.21. 72.21. So up here in the top triangle, 72.21. And then we subtract that from 180, the supplement. 180 minus that 72.21 is 107.79. 107.79. So now for both of these triangles, there are enough degrees to have a angle C. Up here in the top triangle, if we take angles A and B and subtract from 180, angle C down here is 49.79. 49.79. And in the other triangle, where angle B was much bigger, angle C, of course, is going to be a little smaller. This angle C down here is 14.21. So we've got all three angles in both triangles, and now we're just missing side C in the top and side C in the bottom. So we're just going to jump to the chase there. Let's see here. In the top triangle, this side C is 10.27. 10.27. And in the second triangle, the bottom triangle, remember angle C here shrunk, so that means the side across from it will shrink. And down here, side C is only 3.3. So there's some odd problems, one of each, a no solution, a one solution, and a two solution triangle. I hope the video helped.